understand node analysis method. What does it say? Node analysis method says, first is identify the nodes you have in your network. Then arbitrarily, you can take any node at a 0 volt potential or at any reference potential. Like over here, if we say that is we have one node over here and the other node over here. So what we do is we can arbitrarily take it at a 0 volt potential. So this is at absolute reference potential at 0 volt. We have arbitrarily taken it as a reference potential that is 0 volt. Now we can go to the other node, let's say over here, and we say now we apply KCL in this, that is if the current is in this direction, that is if the current is I1 in this direction, I2 is in this direction, I3 is in this direction. So it means I1 plus I2 plus I3, that is obviously equal to 0. That is, once again we know that is KCL only, Kirchhoff current law only. Or we can say this consequence of conservation of charge only, that is at one node there cannot be any accumulation or generation of charges. So I1 plus I2 plus I3 is equal to 0. When you are applying this I1 plus I2 plus I3 is equal to 0, either you take, that is this node is at the highest potential or at the lowest potential. That means either you take all the currents which are moving away from this junction or they are moving towards the junction. Don't take, that is some of the currents they are moving away from the junction and some are moving towards the junction. The things may turn out to be slightly difficult. So the simpler method is you take all the currents emanating out or all the currents which are approaching the junction. Now once we have I1 plus I2 plus I3 is equal to 0, now let's see how we apply this. So once we know I1 plus I2 plus I3 is equal to 0, but we also know that is V is equal to IR. When we say V is equal to IR, that is apply Ohm's law, we know this is the potential difference across the ends of a resistance R, and then I current shall be flowing through this resistor. So over here we have taken one node which is at some reference level, and over here we have taken the node at a highest potential, so that's why all the currents, conventional currents, they are moving away from it. I1 plus I2 plus I3 is equal to 0. Now we say I is equal to V by R, where V is the potential difference. If this is at 0 volt, then certainly this is from here to here, this is a conducting wire. So this is at 0 volt. This positive terminal is at a higher potential as compared to this. So if this is at 0, so potential difference between the two is 30 volt. So this is at 30 volt. If this is 30 volt, then over here also we say that this point is obviously also at a 30 volt potential, absolute potential. Because from here to here there is a conducting wire, all the points in the conducting wire on a conductor, they are the same potential in current electricity. Over here, this is at 30 volt. Similarly, this is at 0 volt, so this is also at 0 volt. Over here, this is at 0 volt, so this is at plus 15 volt. So this is at 15 volt, so this end of the resistor, that is also at 15 volt. We have assumed the current is going in this direction. So if the current is going in this direction, let's say we assume the potential of A as V. So I1 comes out to be V minus 15, higher to lower potential, that is potential difference by resistance by 10. I2 is going to be, we have assumed this at a highest potential V, current is flowing in this direction, potential difference is V minus 30. V minus 30 potential difference by resistance, that is 10. What is I3? I3 is equal to, from here to here current is flowing, that is V minus 0, V minus 0. This we have taken at 0 potential. V minus 0 upon 10. So now we can put I1, I2 and I3 values in this equation. So we get V minus 15 by 10 plus V minus 30 by 10 plus V minus 0 by 10 is equal to 0. I1 plus I2 plus I3 is equal to 0. 10 is, we can take it out common and it goes over here, makes 0. So V minus 45, 3V minus 45 is equal to 0. So V comes out to be 15 volt. We have to find I3. The value of I3 is equal to V minus 0, that is 15 minus 0 by 10 is equal to 1.5 ampere, obviously in this direction only. Had it been negative, it means the current would have been going in this direction. So once again, we get the same answer.